Are you in now?
Okay. My presentation today, I don't have a PowerPoint or the equivalent Impress, so I do have things on a sheet of paper that I will submit that has all the links. And what I'm going to be talking about today is a couple of Windows 10 updates. Seems like I'm doing that. And then after a few of those, I'm going to switch to discussing the new Microsoft Flight Simulator, which runs on Windows 10. And this will consist of a bunch of brief videos, about 8 to 10 minutes, and they talk about various aspects of developing the features of this latest version. And some of the stuff I think will blow you away in terms of what they're doing with this software program in terms of graphics and all that kind of stuff. Okay, so before I get into that, I just want to mention a little issue I had with my laptop, which was it wouldn't log on to my router. The Wi-Fi wouldn't log on to my router. And this problem is, I don't know how it started, maybe with an update, but I'm not sure. And I went through Windows Troubleshoot, and it would go in there and check things out, and it would tell me I potentially had a driver problem with the network board, or it couldn't identify the problem. So my usual procedure is to search Google for an answer, and people did identify problems similar to that, and they suggested things like restarting your computer, turning off the network card, and then in Device Manager, and then repeating that again, and none of that helped. But finally, I got an article which just says you got to look at your services, and I did that. And there's in the services, and I don't know how many of you ever looked at that window. There's a whole slew of services that are running in the background. A lot of them relevant to Windows 10 running, but some of them are not. So when I checked this particular service called WLAN Automatic Logon, it was on manual. So I changed it to automatic, rebooted, and sure enough, that fixed my problem. So that got me thinking a little bit about this services. And the easiest way to get into services is to go down there in the window and type services. There, and then the window opens up right here. And okay, here's the list. Look how long that list is. And so a lot of these things are running, some of them are not, some are manual. That means when you click on the program, that particular thing comes up. And here's the one I want to show you which caused my problem. Way down here, where is it? WLAN. Here, this one here, WLAN config, that was set here. And the way you, notice when you click on one of these things up in here, it tells you what it's all about. Every one of these has a description. So, okay, so this thing here has to do with working your network card or turning it on and connecting to your router. So anyways, it got me thinking about what can we do here to maybe minimize some of this stuff. So I went to the internet, and I have to click on Control Panel for this to work. Here's an article that the link is there. 25 Windows 10 services disabled for performance and better gaming. A lot of us don't really do gaming. I do it with, I'm going to do more of it with that flight simulator, but because that's basically a game. But anyways, the article talks about how to go into services and then how to turn them off and so on. And here's the list that they're talking about. And one of the ones that I found interesting is this one down here, number 21. All join a router service. What the heck is that? Well, let's click on it. And it has to do with linking up with your Internet of Things devices, if you have those in the house. Anybody have those in the house, Internet of Things?
Yeah, I've got about 22 of them.
Okay, well, one of the things that I looked into is there is a Windows Store free program called IoT Explorer for Halloween. You click on that, and it's actually listening for announcements from your IoT houses. So if I just thought I'd look into that and see if I have anything like that in the house. But I had it running for about 5 minutes and nothing came up, so I don't think I have any IoTs. I'd be interested to find out if anybody can use this to do anything with their IoT devices. Okay, so anyways, going back to the other article, there's a bunch of things here that you can tie. Now, the way that works is if you go back to services, there's a number of ways to get into services, but this is one of the easiest ones. If I go back to that, if you click on one of these and then you go to properties, this is where you can control what you want to do. Automatic, delayed start, automatic, manual, disable. So if you disable something and you find out later that it's messing things up, you can always go back and turn it back on. So that's no big deal. So I'm going to go through, especially in my other desktop where I run Flight Simulator, to try to minimize this so I get maximum performance while I'm playing with that game. The other thing I want to talk to about Windows 10 is some of you may know there is a new update. It's called the October update, which I guess is not really available, but there's a way to get it, and I did that. Let me show you. It's the second link. Okay, you go down here, and basically what it's, I won't go into the detail to do this because I have already done it, but basically you go into the control panel or the settings where it says settings down here, update and security, and you go in there for the fast ring down here, and on one of the advanced options, and it's explained in the article that I linked here. And basically what you do is go onto the fast ring, download this update, and then you just can terminate your participation in the fast ring. That's basically what I did. So, and that's discussed how to do that in this particular article. Now, you don't have to do that. You can wait. And I have, in terms of what's available in that update is, I'm going to play a quick video where somebody, let's see, I think I already have that up here. Click that off. Oh, I got something going on here that's not expected. Can't get rid of this. Okay, maybe he's already showing that, sorry. Ooh. Somebody wanting to, okay, I got a bit of a jam up here. Let me see how I get rid of this.
Upper right-hand corner, there's an X by the red icon.
Okay, okay. Let me go to, thank you. Okay, so there's a quick review here in a minute. Right here. And I'm gonna go full screen on this as soon as he starts. Ooh.
Can't hear it.
You can't hear it?
Nope. I can just barely hear something in the background that's really quiet.
Yeah, go up to your options up and on top and share computer audio.
Wait a minute. Options, more, share computer sound. Okay, sorry.
Colored. If you take a closer look at the tile interface here, you'll notice that the tiles are no longer different colors. They're all one uniform color, in this case, white. And that's because we're using the light theme of Windows 10. So the tiles on Windows 10 version 20H2 are now theme aware. They now just copy your system theme, which I think looks much cleaner. In addition to that, the tile interface is also slightly translucent as well. So if we open up a window here, let's open up, say, the Microsoft Store, and open the start menu again, you'll see that the contents of the Microsoft Store in the background here are blurring through the tiles ever so slightly, something you probably won't even notice unless someone points it out to you. But that is a small change they've made to the tile interface, and it looks really quite nice. In addition to that, in the apps list here, you'll see that the sort of square boxes around app icons are gone as well. This is just, again, to improve the UI of the start menu. It now looks a lot more clean and minimalist, and that's what Microsoft is really going for with Windows 10 20H2. So all of the app icons here, you'll see no longer have an app box around them, just the standard icon itself, and I think they look quite nice. Now, as I mentioned, the tile interface here is theme aware, so if I jump into settings here and change my system theme to dark mode, for example. So if we come down here and change our system theme to dark mode and reopen the start menu, you'll notice that the tile interface is now using a dark theme as well, which I think actually does a better job of showing off the translucent effects in the tiles. Again, it's a very subtle design choice, but it's definitely there. So the theme aware tiles also applies if you're using a color in your system theme. So if we go to custom here and scroll down, we can enable show accent color in start, taskbar, and action center, which will make our taskbar and start menu blue, but it'll also make our tile interface slightly blue as well, which is really nice. So that's everything new with the start menu. Again, nothing huge here, but all of these minor changes really make for a nice looking start menu in this release. A much better looking start menu than the previous one, which when you go back to it now kind of looks a bit noisy and messy because of all the different colors and stuff. This is just a much more minimalist and clean interface on Windows 10 version 20H2, and I really do like it. So in addition to these start menu changes, Microsoft has also updated the notifications UI on Windows 10 version 20H2. This is what it looks like. It's not a massive update by any means, but a few things have just been moved around here and there. You'll see that there's now an app icon for the app that's popping the notification. And, again, things have just been moved around ever so slightly. The arrow has been replaced with an X, although its behavior is still the same. I don't know why they changed that, but they did. The X dismisses it and just moves it into the action center, and you can still find it there just like that. Again, a very minor change, but something worth noting in this update. Also new with version 20H2 is the fact that the new Microsoft Edge is now pre-installed. Previously, users had to either manually download the new Microsoft Edge or wait for it to arrive via an update through Windows Update. Now, if you haven't got the new Microsoft Edge yet and you update to version 20H2, the new Microsoft Edge will be pre-installed, just like the old Microsoft Edge was. It's not something you can uninstall because it's the default Windows 10 browser, just like how the old Microsoft Edge wasn't uninstallable, or just like how Safari on iOS isn't uninstallable as well. It's the same case here. This is the default system browser, and it's now pre-installed on Windows 10 version 20H2. And what's significant about that is that with this release, it's sort of more integrated with the system ever so slightly. So if we open up, say, Windows Central and another website, bing.com, and maybe one more website. Let's open Microsoft.com as well. We have those 3 tabs open. If you're a huge Alt-Tab user, you'll see that web pages now show up in the Alt-Tab interface in addition to apps as well. So if I press Alt and Tab here, you'll see that I have my 3 actual apps, as well as the actual web pages inside my Microsoft Edge browsing session. So I have Microsoft website, Bing, and the Windows Central website, in addition to the Microsoft Store, File Explorer, and Mail app. You can configure this if we jump into settings here by going into here, going into System, scrolling down to Multitasking, and then scrolling down to Alt plus Tab. We can change this interface here. So if you don't want to see web pages as their own thing in Alt Tab, you can just say Open Windows Only, or you can show all tabs in Microsoft Edge. So if you have, say, 100 tabs open in Edge, you can actually have them all show up in Alt Tab if you want to, or you can just set it to the 5 most recent, which is what it's set to by default. So if you're a huge Alt Tab user and wished that your web pages would show up in Alt Tab, they now do so with version 20H2. Since we're in settings, we might as well show off some of the additions to the settings app. If we go up to display here and scroll down to advanced display settings, you'll see that you can now change your display's refresh rate straight through the modding settings app. This is only useful if you're using a PC with a display that has different refresh rates. As you can see on my PC, this is just 60 Hertz and that's it. But if you're on a gaming monitor, for example, you might want to go from 60 to 120 to 240 or something like that. You can now do that straight through the modern settings app if that's what you want. And finally, if we scroll down to the About area here, you'll see that there's now a copy dialog for the device specifications and Windows specifications. So if I press on copy here, and then open, say, something like Notepad, I can paste all of that in there like that. And this is only useful really if you're trying to send somebody your PC information or trying to get help through support. You can now send everything all at once, and that's kind of nice. Now, last but not least, Microsoft is updating the behavior of tablet mode on Windows 10 version 20H2. No longer will Windows ask you whether you want to enter tablet mode when you detach or flip around a convertible PC. Windows will instead just sort of enhance the desktop experience so that it's easier to use with touch. So if we open up, say, File Explorer here, you'll see a number of things change now when I move from sort of laptop mode that I'm in currently to tablet mode. So as you can see there, a few things have changed. The hitboxes in the File Explorer app here are now bigger. The search bar on the taskbar has minimized. App icons on the taskbar are now better spaced. And the touch keyboard icon is now available in the system tray. App windows still operate in app windows, and the start menu still opens the start menu. The full screen start experience isn't here. You can still enable that in settings if you want to, and you can of course go back into the action center and enable tablet mode if you want. But by default, tablet mode will no longer come on when you enter tablet mode because Microsoft is now improving the desktop experience with touch instead. Now this is something you can change. If you go into system here, go down to tablet, you'll see this option here, and you can re-enable the Ask Me Before Switching Modes feature, but by default it's now set to Do Not Switch to Tablet Mode, as Microsoft thinks that the desktop experience with its enhanced touch features is better than the old tablet mode experience that's built into Windows 10. Again, it's still accessible. If we swipe in from the right here and press on tablet mode, we can go back to that old tile interface which has full screen apps and stuff, but that is just no longer the default on this version of Windows 10. And in fact, if you're using a PC without a touchscreen now, the tablet mode option here would just be gone. It won't even show up anymore, which I think actually makes sense. But yes, that's the other final change worthy of note in this release. So there you have it. That's a quick look at Windows 10 version 20H2. Not a huge update by any means, but this is the last major feature update for Windows 10 in 2020. And I think the collection of minor changes in this update makes for an overall nice release. So thank you so much for watching, and we shall see you in the next one.
Okay, so that's that. Now, one thing you didn't mention, I'm just going to mention it. They're messing around with the control panel. So click here, and if you go to system now, there used to be a bunch of stuff about the system, but what it does now, it actually goes to the settings. Okay, so apparently in the future, they're going to be doing more changes like that, that when you go to the control panel and you click on one of those things, it's going to refer you to the settings stuff. So he didn't mention that, but that's available too. Okay, so if you can wait for this update, or as I showed you in that one article there, you can go through the procedure and get it if you're eager to see some of this stuff.
Yeah, where is that thing about IoT stuff?
Okay, the IoT is available in the Windows, so go into Windows Store and type in Alljoyn, AAALLJOYN. Okay? All right. So
Okay, thank you.
all right. So the next thing I'm going to do is now talk about, show you a bunch of stuff about Microsoft Flight Simulator. And the reason I'm going to do this is that I actually bought the software at the recommendation of my son, who got his an actual pilot's license 30 years ago, and he's always been a Microsoft Flight Simulator fan, and he uses this to keep sort of his flying skills current. But the reason I'm showing you this is just to see what has happened to graphics and PCs and graphics cards and so on. It's just unbelievable. I'm going to start by showing you the upgrade of there's been, I don't know, half a dozen or more issues of Flight Simulator. And this is a quick historic review of that. And it goes back to the beginning. It's really fascinating to watch the improvements in the graphics. Everybody hear the sound?
Yes, we can hear you.
So this is what it looked like in the beginning. And you see the dates at the bottom left. Here now. It became available in August, middle of August this year. is go to the actual they're going to talk about the various realistic features of this new simulator by the people who actually did the design and programming.
Hello everyone, I'm Matthias, co-founder of MeteorBlue and main developer of our forecast system. Today I want to quickly explain how...
Okay, you jumped the gun on me. Let me stop that. It's a French company called Asobo, and they did a lot of the design improvements and the software programming. The speakers are mostly are French, and the accent is a little bit hard to understand, but they're always written things on the screen to tell us what they're talking about, and this helps. So I'm going to start off by talking about what they call episode 1, feature discovery series about this, and the guy talks about the world, and it's fascinating.
The current work in progress version that we have.
I'll go back to the beginning, sorry. So this is called the Future Discovery Series. I guess they put this out before the program actually became available.
Hi everyone, I'm Lionel Fuentes, lead engine programmer here at Asobo Studio. We are developing the next generation of Microsoft Flight Simulator. As you can see behind me, people are hard at work testing the current work in progress version that we have. So when we started working on Microsoft Flight Simulator, that was at the same time scary and super exciting because there are so many things to do. I will talk about one of the biggest things that we had to do, and this is a key feature for flight simulators, that is the world. I will speak about the world through 4 main points. I will speak about the data sources, the augmentations from those data sources that we could compute on Azure, more on this later. A little bit about the impact on bandwidth, and then some procedural generation techniques that we developed. So, the world, our planet, is really beautiful. It is full of natural wonders, from Ayers Rock to the Himalayan mountains, to also man-made features like the Statue of Liberty, Mont Saint-Michel, the Tour Eiffel. So we wanted to get all of those features in the simulator for you to enjoy. So when we started doing this, we realized how much the world is big. The world is really big, and to the point that we even had to change the internal way we represent a 3D point in space in our engine, like from single precision floating point to double precision floating point, because we couldn't handle that big of a world. And the biggest impact of this was on the amount of data, because you need a lot of data to represent the world. Luckily enough, Bing Maps was here with 2 petabytes of aerial imagery, elevation data, 3D scans for a select number of cities. So all of this data were there, sitting, ready for us to stream in the simulator. This allowed us to get all the airports in the world, which we estimate to more than 40,000, to get all the cities across the world, which we estimate to more than 2 million, to get all the roads in the world, to get all the mountains in the world. Basically, the entire world is there available for you to fly. Not only do you have the entire world, but it also matches the real world. And the big consequence for this is that now VFR flying is available for you everywhere. So for those of you that don't know what VFR means, it means visual flight rules, and it's a way of flying your aircraft by relying on visual cues in the environment, like where you see a given city or a given river. So for example, when in real life we do some piloting, and when in the DR400 we can see the Garonne River here and the city of Martillac there, we can deduce where we're going. The amazing thing is that now we can recreate this very experience right inside the simulator. So I encourage you, once you get the chance to try it, to fly over your house. So we got all those data, but then we needed really more data than that. The reason we needed those data is because we still didn't know where to place trees. We still didn't know what shape building should have, and what color its roof should be, what is the type of roof over there. So in order to generate those additional data, we relied on Azure Cloud Computing. Azure allowed us to run AI algorithms and computer vision algorithms in order to detect all the trees in the world, which we estimate to more than 1.5 trillion. It allows us to improve the building's generation system by detecting the color of the roofs or the roof type. It also adds us to add missing buildings information where we don't have those information in the data sources we use. It also allows us to improve on the quality of Bing Maps aerial imagery. Like sometimes some area can be captured with clouds on top of them, and then we can detect those and replace them with texture synthesis that happens at runtime. So to put some images on what I'm talking about, this is an island in near New Guinea. If we only had Bing Maps data there, the island would be kind of flat and you wouldn't have the trees and the buildings. So thanks to the detection that we could run on Azure, we know where to place trees, we know where to place buildings, we know what the buildings should look like, and this allows us to create a much more believable and precise / accurate representation of the Earth. But what about the impact of my internet connection? Because at this point, you may be wondering, we are streaming all of those data, like Bing Maps data, Azure augmentation data. We represent the entire world. So what happens if I don't have high bandwidth available? What happens if even I have no internet connection at all? We ask ourselves this very question, and I'd like to answer it through 3 main points. The first one is that we do adaptive streaming. What this means is that we measure real-time the bandwidth you're using and adapt our bandwidth requirements according to this measure. The net result of this is that the better your bandwidth, the better your overall experience. Next, we developed a full offline mode. So this is for the extreme case where you have 0 available bandwidth. We synthesize the ground textures, and we also still have all the buildings data and all the water data, and for some regions also the trees data. So the result of this is that we still have a world where VFR flying is possible. It gives us a reasonably accurate representation of the world. And the third point is that we can pre-cache arbitrary regions of the world. What this means here is that you can select regions of the world that you want to pre-cache, and you can access them in an offline setting while still having the same quality you would enjoy in an online setting. To put some images again on those words, I will show the 3 different quality levels that you can experience. First one here, offline mode. This is the Seattle area in offline. And as you can see, all the buildings are there, all the water information is there, and the city is recognizable. Second here is online Paris. So the majority of buildings here are being automatically generated, and you also have the water information, and it's a more accurate version of the world. And here again, VFR flying is possible. And third here is where we have the best quality. This is the city of New York. You may have recognized it. This is when we have photogrammetry data available in Bing Maps for more than 400 cities. But now, how about the fine details? Because it is impossible to accurately capture all the very fine details of the world. Like you cannot know exactly where each blade of grass is, or which precise details you have on a given building. So in order to add this level of precision to Microsoft Flight Simulator, we relied on procedural generation. We are adding ground details for dirt, grass, and asphalt. We generate grass blades, actual 3D geometric grass blades. We display millions of them on screen. We also add water shading, up to the point that we even have the water affected by the wind, which creates waves on the water. We also add night lights, both along the roads and on the buildings. We also add details to the buildings. And all of this helps create a much more believable world. As you can see here, this is taken in Bretagne, France. And as you can see, you have the procedural grass being generated. You have those little houses that are generated. You also have those trees that are being generated procedurally. You also have the water shedding for the sea. And it gives a much more realistic representation of the area. So this is it for the world of Microsoft Flight Simulator. We hope you really enjoy it as much as we do. Thank you very much.
Okay, I mean, you get the idea here of what they've done. You can go anywhere in the world. All the detail for the entire world is available, and you can fly there. Okay, so the next one they talk about is the weather, and this is really intriguing because what they did really improve is the clouds, and he'll talk about that. Okay, so here's the weather. What's really intriguing is the clouds. They've done a heck of a job on the clouds have volume, which they never did before. But
hello everyone, I'm David Deden, Creative Director at Asobo Studio, and I'm super proud and happy to talk about weather today for the new flight simulator. There is 5 important things we want to cover today about this new atmospheric engine in order to unify the rendering of the sky in the simulation. Everything related to the weather special effect, also the new day and night cycle, the volumetric clouds, and the live real world weather implemented natively in the game. So to start with the new atmospheric simulation, we had to completely restart from scratch this aspect of the sim because we really wanted the lighting of the world to be as realistic as possible and to take advantage of new techniques coming from the video game industry to make this as best and as realistic as possible. So in this case, the new scattering systems allows us to unify all the different sources of light and to render all of them all together. Typically, the sunlight, the moonlight, the starlight, the city lights, all of those things are informed by the air density, by the humidity of the air, even sometimes by the pollution. And all those different layers of atmosphere are taken in account to scatter all the photons coming from those different light sources. So the shadows have also been really improved. Now the mountain casts shadow on the clouds, the clouds cast shadow on the mountains, the clouds cast shadow on themselves, and all of those different layers of clouds cast shadow on the ground, which gives a general feeling of realism which is never seen before. So now, what about the new weather special effect? We've got now a fully volumetric 3D rain natively in the game. We also have a volumetric rainbow scattering. It's really based on what would happen in real life. If you have the right context, the right level of humidity, typically rain, and the right angle, you will see a rainbow where you would see it in real life. At the level where actually, as in real life, most of the time there is an echo to the first rainbow, and you can see it in game. You can see the echo of the first rainbow propagating in the atmosphere because it's a scattering calculation, so it works as in real life. So the rain impacts also the cockpit itself. Each water drop on the windshield is informed by the speed of the plane or the thrust of the engine. Depending on this, you will see each drop of water being stretched on the windshield, which is pretty neat. We also have a fully volumetric fog. We also have the icing, depending of the real-life parameters and context. So we will see the ice propagating on the wing and with all the systems that allows the pilot to de-ice the wing. This clip is cool because it shows what I was talking about. You can see this cloud in the middle of the picture, which is lit directly by the sun because there is a hole in the cloud ceiling, and the other clouds all around are darker. And it works also for the rain that you can see under the cloud, which is lit directly by the sun too. So we can see the nice movement of the rain. So it's a time lapse, so it has been slightly accelerated in order to demonstrate what I was talking about. Here you can see the rainbow, and if you look at it closely, you can see the echo of this rainbow behind it, again, because it's really based on physical calculation. Here you can see the rain impact the cockpit rendering and typically the way the water propagates on the windshield itself. And you can see that depending on the speed, the drop of water will be stretched in the direction of the wind, which is pretty neat. So we have also improved the night engine. So now we are talking about a fully yearly based day and night cycle. What it means is that the position of the sun will be really informed by the moment of the year. Summer, the sun will be higher in the atmosphere in the north hemisphere, obviously, and it will be lower during the winter. But it's the same thing for the position of the moon, depending on the moment of the year or the month. Same thing for the stars, which will have their accurate position in the sky. We have also completely revamped the lights on the ground. So the city lights, the road lights, the runway lights, or the airport lights in general, all those lights will also inform the rendering. You can see the clouds being lit by the city by night. And it allows, as a result, VFR navigation by night, which is pretty cool. All the reflection also are taken in account. So you will see all those lights reflect on the water, for example, which is also rendered as any layer of the atmosphere. It sounds weird, but it's actually the case. So you can see on those videos that during a dark day, the water will be super dark and the reflection of the buildings are really dark. And in a bright day, you can see that suddenly, in this case, the Seattle Bay is pretty colorful, and you can see that the ocean now is at the same spot, much more blue due to the color of the sky and the reflection of the building themselves. It's much more colorful too. So now a few words about the volumetric clouds. To us, they are a little bit the star of the show, because obviously they are super important during a flight. They are generated based on 32 layers from sea level to high altitude. Each of those layers are informed by fuzziness, density, cloud shape, and all those clouds can be seen from any angle. There is no billboard effect. It's truly fully volumetric. They are not only visible from any angle, they are also informed during their life by the updraft, the wind, their dissolution, their formation, that you can see if you observe them exactly like it would be in real life, informed by the real life weather. So it's really neat. Thanks to this system, we basically have a native support of all the cloud types, depending of the width of the layer or the density of the layers. We can basically display any type of clouds thanks to this system, which is super cool. And we simulated this all around the globe, and the view distance is 600 kilometers, which is really important because especially when you fly in airliners, you can see them from very far, and we still have the same level of accuracy, which is really great. In this video, we can see that even inside the cloud, the density of the cloud can evolve, and that when we go under them, you can see that the clouds cast shadow on themselves. Those two layers of clouds also cast shadow on the ground. On this one, you can see how the updraft informed the formation of this storm. As a result, now I would like to show you this video where we can see the different type of preset we've got in the game. You can change them on the fly, from clear sky to broken sky to stormy weather to rain, etc. All those presets are accessible directly from the in-game interface. So I would like to show you now something pretty cool that you haven't seen before, is the ability for the user to change seamlessly the time of the day just with this slider. It's real time, no loading, and it's really cool. Hope you enjoyed it. So now a few words about the live real world weather. Based on everything I've said so far on the weather system, the architecture of the rendering of the weather has been made in order to also be able to receive real world data and to inject those data directly in the engine to represent the real world as close as the data we actually collect all around the world. Those data are somewhere around 60 different layers everywhere in the world. Each of those layers, again, define the level of humidity, density, fuzziness of the different clouds type. We inject that directly in the engine, and it gives us as a result exactly what we would observe in real life. If there is a cold front in real life or hot front in real life, a storm, if it rains somewhere, all of that will be directly injected into the engine and will reflect what happens in real life. So on top of the information related to the clouds themselves, there is also all the information related to pressure, to humidity, to temperatures, to wind gusts. So as a result, we have a native support of jet stream, for example. So your navigation will be based on actual weather information that you will have to take in account, which is super important, typically for airliners, where the navigation is really based on the speed of the wind on higher altitude. So on this video, you can see a screenshot of a website with real-life data, how we put this in the menu of the game, and how you can actually see the exact same clouds in-game. So to conclude this video, there is 3 highlights. The fact that we have a full spectrum weather that you can edit on the fly, real-time, seamlessly, that we have a fully volumetric sky, and also that the live real-world weather data can be injected natively in the engine and gives you exactly what you would have in the real world. So I hope you've enjoyed this video. Thank you for watching. See you soon.
Okay, I'm going to follow this one up by another video about the weather creation. And they rely on another company, a Swiss company that provides weather information worldwide and weather forecasts. And he explains how they do it. And I understand from my son that the real weather thing is not quite yet available in the software at this point. They're still working out the bugs. But let me go down here, and this is a partnership. So they had people working with them on the specifics, and this is also very interesting. The company is called Medio Blue.
Hello everyone, I'm Matthias, co-founder of MeteorBlue and main developer of our forecast system. Today I want to quickly explain how Flight Simulator knows about the weather and how we actually create a forecast. Basically, we start by dividing the Earth in a number of small boxes. For every box, we need to define the weather. And we do this by storing temperature, wind speed, humidity, pressure, rain, snow, and pretty much everything that defines the weather. So now that we have stored that, we can have different weather in every single box. Obviously, for flying, we are not just interested in the weather at the surface, but also at higher altitudes. The way we solve that is by adding one more layer on top of that one, then another one, and another one, all the way up to the stratosphere.
To provide such global weather data, Microsoft found the perfect partner in Swiss company Medio Blue. Medio Blue is a specialist weather company producing, managing, and supplying high-precision weather and environmental data for the entire Earth. Using observation data, high-resolution numerical weather predictions, and immense archives of historical data. Medio Blue was founded in 2006 as a spin-off from the University of Basel, Switzerland. Since then, it has grown from a 2-person startup into a company with customers in more than 50 countries. Medio Blue has pioneered technology breakthroughs from its inception, as CEO Karl Gubrot explains.
Innovation is our DNA since the beginning, and this is expressed in some of the step changes made by Meteor Blue in the weather business. One was this 2-kilometer weather model covering all Central Europe on an operational basis. We then followed with several high-resolution models for Africa and South America with 10 to 18-kilometer resolution, unique at the time. And 2013, we were the first private company to run a global weather model 7 days ahead with hourly intervals.
The Meteor Blue website has pioneered many visualization forms, such as meteograms with vertical cloud structures, multi-model forecasting, and graphics to compare all major weather models. Several generations of wind particle simulations, with first versions starting in 2003. Easy and clean access to all the METAR and TAF information for flight preparation. And starting this year, the first vector-based interactive weather maps, providing a proper scientific visualization of weather data on the web.
Flight Simulator is a project where there was virtually no limit on how much data we can provide. So we decided to have globally 250 million of these boxes. So now Flight Simulator knows about the weather not just at the airport, but everywhere. Especially for the clouds, we added 60 vertical layers on top of each other, which then allows us to create this incredible amount of detail we see in the simulator. But how does the forecasting work? Well, let's do a simple experiment. I have a battery, which I place on this small slope, and if I let it go, it will roll down and eventually stop. Now, the question is, why is it doing that? Well, basically we have two forces acting on it. At the beginning, it's gravity that accelerates it, and then we have friction of the table that slows it down. So, if we know the forces acting on the battery, we can put those into mathematical equations and create a system of equations that's predicting the time evolution of this battery, so we know where it will be 30 seconds from now. With weather forecasting, the process is pretty much the same. The only difference is we have more variables and the equations are much more difficult. Now there's another important point to note here. The end result of our simulation is very much dependent on where we start. The starting point is called initial conditions. And we find these initial conditions by taking measurements. So these are ground stations, satellites, or even airplanes. Now when we measure the initial conditions, we cannot do that with infinite accuracy. So we could say we measure the starting position accurate to 1 centimeter, and then we let those go. We see both go to the right, which could be sunny weather. However, this small inaccuracy of 1 centimeter could lead to very different results in some situations. And this is why sometimes the weather forecast is very accurate and sometimes it's not very accurate. Well, the way to figure out if it's going to be accurate or not is doing this. So we compute many forecasts and see how much they diverge or if they all go at the same place. Now, the real benefit of having all those models accessible is the possibility to combine them into one single forecast that is much more accurate. This is a real big data problem. Over the past years, we developed our own specific machine learning methods to solve the problem of finding this best combination. And it is this forecast we then publish on the website or sell to our customers. When we started working on the Flight Simulator project about 2 years ago, we were thinking about including forecasts for airports and maybe some upper level winds so that pilots can fly in the jet stream. But then the project grew so quickly and could ingest more and more data that now the weather looks almost like real. So in the current version, we included the full 3D icing risk data derived from cloud microphysics. This is a variable we weren't even thinking about in the beginning. The partnership with Microsoft has been really exciting for MeteorBlue, as the innovation simply never stops. As you can imagine, here at MeteorBlue we work a lot with code, maps, diagrams, but with Flight Simulator, even for us, it's the first time we can really experience the data we compute.
That's an interesting comment that he makes at the end, that they can experience their own data. How about that? Okay, so the next one is going to be about the aerodynamics of how they control the actual simulated airplane. And let's see how.
Hello everyone, I'm Matthias, co-founder of MeteorBlue and main developer of our forecast system.
I gotta shut him up.
Today.
Sorry about that. Let me get the next one, aerodynamics.
Might we take a short break?
Oh, you want to take a break? Okay, 5-minute break. 5-minute break. Let's see, it's 12:05, 12:10.
Hey, Len, it's Scott. I just wanted to tell you this was absolutely fascinating.
Isn't it though? Yeah, it's
very cool. Very cool. Are you going to build a room in your house so you can fly around?
Okay, I am just going to keep it simple. I just, as I will mention later, I only, at my son's recommendation, bought the standard version. There's 3 versions, and I'll if we have time, I'll show that that are available, deluxe and premium and deluxe versions, which are a little bit more expensive. The cheapest version is about, what, $69, and then there's one at, let's see, what are they? 89 and 119, and they're already starting to discount them. Yeah, you can do, you know, and then there's peripheral stuff. I just bought a $40 joystick from Microcircuit to do it. You can do it with a mouse and with a keyboard, but the keyboard is really clumsy. The mouse is not much better, so a joystick is kind of necessary. And the joystick has buttons so you can program different things. Now, one of the things you can do is, and the pictures kind of show that, is that you can see there's like a drone image. You can see the airplane from the outside, like you're sitting in the cockpit and you see the world looking out, but also there's a way to look at the airplane from the outside, and as you're guiding it, you can see the model responding. And that's kind of neat. At the same time, you can get a better view of what is the surroundings and all that. So it's really fascinating in that regard. And what's blowing according to my son, who's been Microsoft Flight Simulator aficionado for the last 30 years. I think he's bought every one of the versions, as have many other people they talk about. They're blown away by these volumetric clouds. The clouds, he says, are so real that he just couldn't believe it, how real they are when he's flying with them. And you can saw that where they actually fly through the clouds, and the way the multi-layer clouds, which happen. I'm sure some of us have flown through those. We have a second layer, and you're in between the layers, and the light, the way they handle the light is just amazing. And to do that all on a PC desktop, you need maybe a little bit better than average machine. and I'll comment on that. What I've got, the biggest hurdle is the basic software is 103 gigabytes. It took 3 hours to download.
Yeah, that's very interesting. When I've got a friend that an associate from GM that has like an entire room in his house and multiple screens and all that kind of stuff. A full cockpit and probably $10,000 or more in all the joysticks and foot controls and all that kind of stuff. I've always wanted to go see what he's done.
Well, you should go. Hopefully, he's downloaded the latest Microsoft. There's a couple of other programs available, but I think with what we've seen so far, I think people are, the simulator users are just blown away by this, especially where they talk about simulating real weather in real time. As I said, it may be not quite available yet, but they're working on it. And of course, there's issues people are finding. For example, I just read that somebody was flying, and all of a sudden the images went into a black hole kind of thing. But they'll work out these little problems. And look at that, they've been working on this for 2 or 3 years. So.
Well, letting my mind go completely wandering, it seems like they, someday a commercial pilot might want to fly the landing 15 or 20 minutes before he actually gets to the place where he actually has to do the actual landing. That would be a huge improvement in safety.
Yeah. Some places in the world. Yeah, I don't know. There's like I said, the joystick is only $40, but there are things available with additional, like the yokes that they have on planes and the joystick and the foot pedals and so on. And you're starting to talk hundreds of dollars, but I'm not ready for it. Personally, I'm not ready for that yet. Okay, there's still some people missing. I'll wait a few more seconds here. A few more minutes.
Can you hear me?
Okay, Carlos is back. Yeah, I can hear you.
Just a question, what browser are you using?
Currently, I'm using Firefox.
Oh, Firefox. How about IE10? Can that be used also?
I don't know. Never heard of it. IE10, Internet Explorer 10?
Internet Explorer.
Yeah, well, the latest version, as I understand it, is 11. I suppose you can run it, but some of these older browsers can't handle what's on the newer website. So I urge you to upgrade to the latest versions. Okay. You might have trouble. You might have trouble logging on to certain websites or seeing certain things.
So I should get Internet Explorer 11.
No, you should get to this thing here. You should get to the latest Microsoft Edge, Microcircuit Edge.
Microsoft Edge, that's the latest.
Yes.
Okay, well, I'll switch to that.
Okay, the people are still missing, but shall we continue?
I'm listening.
Let's continue.
Okay, all right. This one is on aerodynamics.
Hi, I'm Sebastian Bloch, CEO of Asobo Studio, and today we're going to talk about aerodynamics. When we started working on Microsoft Flight Simulator, we first studied all the code that has been written on Flight Simulator X. There's been many years of work on all the code base, and the code base of the simulation of the aerodynamics was pretty huge. I will cover 5 areas of improvements that we made to the Flight Simulator aerodynamics and physics. First, we made improvements to the core simulation engine. Second, we made improvements to the actual simulations of the different systems of the aircraft. Then the biggest area we reworked was the aerodynamics. We reworked the aerodynamics simulation from scratch in the simulator. I'm going to go over the details of how the aerodynamics simulation now works. One big area that we reworked was the weather system. The biggest interaction of the aircraft is with the air. It's the air that makes the aircraft fly. And so we reworked how the air was simulated in the world. We're creating a full simulation of the airflow over the planet. And I'm going to explain how the airflow interacts with the world, the environment, and also with the weather. The first big improvement we made to the core of the simulation is a better collision model with the environment. So the system now supports sloped surfaces, which means that aircraft can land on sloped runways, but also on any slope in the world. Aircraft can now land on a sloped field. For example, if you want to simulate an engine failure, you can make a cross-country landing on any surface, including sloped surfaces like fields on mountain slopes. It's going to work anywhere. To make sloped surfaces work, we had to rewrite the friction model of the aircraft. So tires are now correctly simulated with dynamic friction, static friction. All the friction parameters have been improved, and so like the rubber now really behaves on all different surfaces like tarmac, cement, grass, earth, exactly like it should. And also on slopes, if the tires start to skid, they're going to skid exactly like they should with realistically simulated dynamic and static friction. So we also improved the way the bumps on the ground are handled. They are now realistically simulated, and the way the brakes are simulated. So this allows for planes to come to a full stop even on slopes, and that's when they transition from dynamic friction to static friction, and planes can really come to a complete halt exactly as they should on slopes. So when you do a landing on a sloped runway, you can now roll and you can stop on the slope, turn around and take off again. We also rewrote the integration system of the simulation. So the integrator is what makes the simulation go forward. It calculates all the states of the system. So one thing we changed is now that the simulation is running at a much higher frame rate, but the frame rate is adaptive, so it adapts to the frame rate of your actual TV or monitor. This means that the simulation is much more smooth. Whatever the frame rate of your display, even if you have slower frame rates, frames are exactly going to match the display. And also the simulation is always going to run at a higher frame rate. So even if your frame rate goes down, the simulation stays at a high frame rate and you don't lose anything of the realism. Planes always behave as they should, whatever the frame rate. Another big change we made to the integrator is the way the integration now works. It's much more realistic, and it has removed one artifact that was present in previous versions of Flight Simulator, which is that planes felt like if they were on rails. It's because the old integrator was resisting change, and it was forcing planes to always move more or less in a straight line. So the integration is now super realistic. It's exactly moving the aircraft as they should in the world. Spins are much more realistic now, and planes don't feel on rails anymore. So we changed that and removed the effect of planes being on rails. We also reworked the inertia matrices. They are now more realistic, which means that the mass distribution of aircraft feels more real, and planes, when they rotate, when they yaw, when they pitch, when they roll, they feel much more realistic now as they travel through air. So we also made improvements to systems in the simulation other than aerodynamics. We improved the load factor simulation, which also improved the way the turn coordinator is simulated. It's now much more realistic, which means that when you fly asymmetric, which means that if your aircraft skids a little, the ball is moving to the side exactly as it should. And you can now control with the rudder your flight and make it symmetric using the ball much more easily, because it reacts much more realistically than before. And so we have now specific fuel consumption, which is realistic per altitude level, and which is matching the actual POH of the aircraft. We improved the way flaps can be set in the files, which allows to have more control We finally reworked the way gears and external parts like external tanks are simulated. Instead of just hard coding the moments they apply on the aircraft, they are actually physical elements in the airflow which are attached to the airframe outside of the aircraft, and they now are realistically simulated aerodynamically just like the aircraft and apply their own forces and moment exactly where they should, how they should. We also improved the icing system. So icing is now simulated realistically depending on the actual humidity of the air around the aircraft, and because the weather system is now accurate and simulated volumetrically, if you fly through clouds, you're going to get a different icing than if you fly through dry air. And so this is now simulated in 3D volumetrically. Also, what we did is the legacy simulation code from Flight Simulator X is still available. So you can switch to the legacy simulation if you don't like the new simulation. We don't want to force anyone to move to the new simulation. So all aircrafts have been reviewed with professional pilots who have many hours flying these aircrafts, or test pilots from the manufacturers. So we've gone over the aircrafts which were already matching POH when we presented them, but to make sure they actually are controlled exactly like they should, there's many parameters that we set that are not actually present in POH, such as how fast the aircraft is going to roll when you move the yoke to the left, for example, depending on your airspeed. This is data that is not always available, but that professional pilots feel. They know how agile the plane is at what speed. And so these are parameters that we set with them. And we reviewed the whole aircraft to make, for example, stalls as they should be, or if an aircraft can spin or not, or the way basically they behave so that they don't just match performance parameters from the POH, but actually feel as the real aircraft when you fly them in real life. So the big change we made to the system is the aerodynamic simulation has been reworked. So how we simulate now is much more advanced. So we subdivide the aircraft into thousands of surfaces which are mapped over the airframe. So for example, over the wings, over the fuselage, over the wheels, over the tail. There's thousands of little surfaces which are placed exactly where they should over the geometry of the aircraft. Each surface goes look at the weather, so it has its own wind direction. It's going to have its own air pressure, its own humidity. This means that the right wing, for example, can fly through a cloud where the left wing doesn't, and you can have different wind, turbulence, and humidity on the right wing. Each of these surfaces has a realistic airflow simulation. Each surface is going to have its own wind direction, its own air pressure, and it's going to do a full three-dimensional calculation to compute what is the force and moment that should result from the airflow flying over the surface. This simulation includes the airflow, speed and detachment and orientation. It will realistically simulate stall. The stall is when the airflow is actually bent too far by the surface and the airflow cannot stay attached to the air surface anymore. So this is now simulated surface by surface, which means that we can have a left wing stalling, especially because of the weather and the full realistic simulation of each surface in the world. But each surface will also deflect the airflow. The airflow is going to be impacted, and surfaces which are behind are going to get a different airflow because the airflow was impacted by the surfaces in front. So this, for example, is going to allow more aerobatics. So for example, the airflow is coming from the propeller and is hitting the tail. And that's how you can, for example, enter into a flat spin or some of the figures. So for example, when you could do an inverted spin, that's because the propeller hits the tail. And this is now realistically simulated. The big improvement we made to the simulation is the simulation of the air mass. We now simulate the air mass globally over the entire planet and realistically. Every area of the world has its own simulation of air, and we know where the air is flowing everywhere on the planet, and this then feeds into the aerodynamic system of the surfaces of the aircraft. So this means that, for example, we will have volumetric clouds, which you can see in the world, which are going to match the airflow. For example, on TCUs, on towering cumulus clouds, usually it's a kind of cloud which exists because there's a lot of updraft of air. But when they get really big, there's an updraft on the side, and in the middle it actually goes down. That's basically why they're so dangerous, and you should never in a small aircraft get close to a TCU. In a big aircraft, you're going to get a lot of turbulence. And so this is now simulated. The airflow in the world is going to match the clouds, and it's going to fly. The air is going to move up and down inside of the clouds. So you will see a video which is going to show this airflow. So in order to visualize the airflow, we release thousands of particles in the world. and displayed the trajectory of the particles. They just do exactly the same calculations than the aircraft in the world. So each particle samples the world atmosphere exactly like each surface on the aircraft. So you can see on clouds that the air is moving up and down. You can see the turbulences, which is when the airflow of the particles changes color and the particles move more randomly. So these are like wind shear or turbulences. Some of the air may go up because it's in the middle of the cloud. Some may go down, and at the edges you get shear. So this is all now naturally simulated. And we have all the updrafts and downdrafts in the world which match actually the weather. So this air mass simulation also works with the world shape, like the shape of the world, which can depend on buildings, hills, forests, mountains, valleys. So all these different shapes worldwide are going to influence the airflow in the world. So for example, the air flows over a stadium or a hill. It's going to create updraft, so the wind is going to flow up. And on the other side, usually it goes back down, but in a turbulent way, right? It has to go back down, but it's going to be creating a lot of rolling turbulences. So you can imagine when you fly over this air with the aircraft, if the aircraft is flying slow, if it's a small aircraft, it's going to get all these rolling moments, it's going to get the up and down draft, and you're going to feel all these bumps. So on the video you're going to see there's, for example, wind flowing over mountains, and it naturally creates turbulences. On the other side, in the valleys where the currents come together, they collide and it creates these turbulences. You can see in the middle of the valley, you can see the up and down draft, and you can see how the slope of the wind is actually very, very steep, right? It goes along the slope. So this is it for the improvements on the aerodynamics, on the physics. So we improved the core simulation, we improved many of the simulated systems, we reworked the aerodynamic simulation with the surface-based system, and we reworked the simulation of the airflow in the world. All these changes come together to create a much more realistic simulation of the aircraft. Aircrafts are now simulated realistically to the performance data that is available. They fly exactly to the real-world performance, but they also feel exactly like real aircraft. They turn, they behave when you move this yoke exactly like a real aircraft, and they fly through the world. They fly through the air exactly like a real aircraft flies through the air in the real world, being impacted by clouds, by mountains, by buildings, by the shape of the world, right? I hope you enjoyed the details I gave about the simulation, about what we changed. Thank you for your time. Please subscribe to the alpha.
Okay, so the next one is gonna do all this. There's one on cockpits and soundscape, so I don't know how much time I've got left here, but I'm gonna go to soundscape episode 5. And then if we have time, I'll go back. Just surprising how much trouble went to get all the right sounds for everything.
Hello everyone, I'm Aurélien Peters, audio director at Asobo Studio, and in this episode, I'm going to present the audio features of the new Microsoft Flight Simulator. I will begin by presenting the new audio technologies, what was improved, and how these tools help us build an accurate soundscape. Then I'll show you how we created aircraft audio, how we recorded them, and how we use the recordings in the simulation. At the end of this episode, I'll talk about the world and the weather. And as my colleague Lionel said,
the world is really big.
Audio is here to support and enhance the world in Flight Simulator. The audio engine has been totally revamped and is now using Audiokinetic WISE. WISE allows us to use the latest interactive audio technologies, such as real-time audio effects or even dynamic mixing. These new technologies gave us a huge freedom and allowed us to simulate sound reflections, cockpit acoustics, or even Doppler effect. But what was most important to us was to connect audio to the simulation, meaning that every sound in the sim is connected to simulation variables. By doing so, the audio is accurate and feels breathing. For example, if the wind is getting strong or if your plane is shaking, the audio will reflect those changes. It really gives depth to the simulation. The good news is that the SDK will allow you to access all these simulation variables. We created a new way to implement audio, using XML files and WISE. All these files will be accessible to simmers, meaning you'll be able to tweak or even add sounds. We also made sure that the FSX legacy audio content was still usable in the new Microsoft Flight Simulator. For aircrafts, the most important thing was to reflect the sonic signatures of every aircraft. For this, the best solution was to record them to get an accurate result. Our partnership with plane manufacturers allowed us to visit plane factory and have full access to the planes. We created a recording rig, allowing us to record with high fidelity, 16 channels of audio for cockpit and external perspective. Each microphone is recording specific elements or perspective: front propeller, side propeller, close exhaust, far exhaust, and so on. This modular approach let us create specific audio emitters for each sonic source, bringing a true 3D audio experience. For example, if you get close to the exhaust, you will hear more of it. Following your position game, you will never hear the same thing. More than the engine, we also carefully recorded cockpit buttons, switches, instruments, or even flaps. Last but not least, thanks to audio convolution technology, we were able to record cockpit acoustics, which allowed us to play any sounds or voices as if you actually heard it in the cockpit. For example, if you wish to create new sounds, it will allow you to play them in the acoustic space of the cockpit. With such a realistic and detailed world, we wanted aircraft and every sonic source to be fully integrated into the environment. We wanted the audio to feel right in the world. For this, we needed to totally rework the way sounds were attenuated and reflected. For example, when a plane is passing from far away, you not only hear the direct sound of the engine, but you will also hear all the sound reflections. Like in real life, when the sound is bouncing back to you because of the mountains around you. Moreover, we also totally reworked one another key aspect of the soundscape, the Doppler effect. Depending on the speed of the aircraft passing by and your own speed, the engine pitch will be modulated, as it would in the real life. Attenuation, reflections, Doppler effect all together brings accuracy and give an organic feeling to the sonic source of the new Microsoft Flight Simulator. As I already said, the connection between the sim and the soundscape was really important to us. And this time, we used the most of the physics and aerodynamics calculated by the sim to feedback how the plane was behaving. When your plane is checking, or when you're doing a far from perfect landing, you're going to hear the impact and the physical rattle of the plane. A really useful feedback to determine how successful your landing was. We also simulated the aerodynamics wind flow on the plane using wind sounds. Especially in external view, where we can have more creativity, you'll be able to hear your actual plane movements. the new flight simulator, you'll be able to land everywhere a plane can land, meaning that you'll be able to hear the soundscape of where you land. We created a biome system based on the SimLAN classification data. Depending on where you are, you'll hear different soundscape. For example, you will get a very different kind of fauna sound in the African savanna than in the Alaskan area. We also simulated the night and day soundscape with different ambience at night time. As for more aviation-related sounds, you'll be able to hear surrounding planes or even ground vehicles. The idea was to enhance immersion and support every story the world is telling thanks to audio system. Weather tells its own story, and in Flight Simulator, there's many variables for you to tweak, and each of them is connected to audio. Let's say you increase the wind. You'll not only be able to feel the wind during your flight experience, but also hear the wind. We also have rain, thunder, and even storm for a complete weather experience. Thank you for watching this episode. And on behalf of the Flight Simulator audio team, I hope you enjoy hearing the world we created for you.
Okay, the next one I'm going to do here is I'm going to do the one on airports. There's one on cockpits, which gets kind of technical, but we can come back to that if we have time. But I want to do the airports one.
Hi everyone, and welcome to this new episode of the Feature Discovery series. I am Sven Mestas, lead game designer at Asobo Studio. In this episode, I'm going to talk about airports in the new Microsoft Flight Simulator. First, I'll begin by presenting how we are covering the various types of airports, both geographically and by scale. Then, I'll explain the work pipeline to treat each of these airports from big aerials to their final state in Flight Simulator. Finally, I'll present to you airport life and talk about services, ground traffic, and air traffic. The previous version of Microsoft Flight Simulator, FSX, simulated more than 24,000 airports. The new Flight Simulator features all the airports in the world, including 37 manually edited airports. This coverage begins at small countryside bush airstrips, all the way to huge international airports. Geographically, you'll find airports all over the world, nestled on small islands, adjacent to major cities, and perched on mountainsides. North and South America, Europe, Africa, Asia, and Oceania are all represented. Before editing airports, we needed to first create a database. We started from the FSX collection and decided to add more airports to give better coverage and a larger amount of locations to explore. After lots of triage and selection, we edited 37,000 airports. In order to reach a new level of reality in flight simulation, we needed a new approach. That's why we decided to innovate by editing airports from real aerials and satellites pictures. This technique involves editing each airport manually, which means particular attention to details has been given to every single one of them, to bring them a step closer to reality. This work has never been done at this scale, and that's why we needed to create a specific tool for developers to handle airport editing. Now, I'll take you through this edition process. This pipeline has been used for every single airport. Step 1 is to trace logical elements straight on the Bing map aerial. We begin by drawing the airport perimeter, which will force the building type generation when it will occur. Next, we draw the runway with as much accuracy as available by defining its real length and width. Its orientation will determine its numerical markings according to magnetic north. After that, we define taxiways based on the real ones, which will be used for ground traffic, air traffic, ATC, and simmers. We place the parking spots at the exact same place of the existing ones. Finally, we reproduce markings on the apron. The second part is defining surfaces. According to the observed material on Bing aerials, we edit surfaces. It can be grass, concrete, dirt, etc. This process allows us to capture the real identity of the runway and to apply accurate materials onto it. Of course, it leads to different behaviors, impacting the landing gear grip, for instance. If there are any visual artifacts on the grass, such as planes, we draw perimeters to remove them. The final part is the post-processing. These steps are automatically performed by our algorithms. The runway slope is applied for chart references. Materials are applied on generated objects, allowing us, for instance, to see reflections on runways, wet materials, tire marks, etc. The visual artifacts on concrete are automatically removed. Contrasts and colors are adjusted to match real life. Names are attributed to taxiways and signs are generating along them. Animated windsocks are generated as well. These are even able to follow the wind direction when it changes. We also improved the light generation by having them spawning along the runways and taxiways. Because some airports deserve more attention, we made a selection of 80 airports based on the most played and busiest ones. We gave these airports more realism by naming the taxiways and signs according to official IDs and providing them more accurate surface definition. Beyond that, in order to take things further, we created a top-level category. We defined a final selection made of iconic airports and dressed them up to reach a new level of realism in flight simulation. We created and placed unique buildings and props matching reality, transcribing their identity and their ambience, and we even terraformed some landscapes to nest them in their real environment. Now, let's talk about airport life. Life is supported in every airport of the game according to the size. As in FSX, we kept the ambient ground traffic in airports, but we've made improvements. We filled airport parking lots with vehicles to provide a more realistic look. We tweaked vehicle behavior. They come and go on taxiways, but now they stop at all shots even if the runway is free, and they are able to turn on their lights at night. We included workers as well. They move between various points, bringing life to the apron. Services are now accessible from the ATC on a specific ground frequency. We kept services which were already set in FSX, but made various improvements. Gateways have new visuals and a more realistic way to attach exit doors, fitting more precisely with the fuselage. pushback vehicles now feature drivers.
Marianne?
The baggage service has workers as well, and we set a realistic trail behavior on baggage carts. Fuel services have been improved as well. When a fuel truck arrives, it plugs itself to the refueling hose. It automatically opens the fuel panel, allowing you to tweak your fuel settings. The same panel is open when you go to the fuel station with your aircraft. We added some services in order to allow you to complete your ground handling in a more realistic way. You can now call a ground power unit, which will be plugged into the aircraft through a cable. A ramp trunk is now available when you are on the right parking spot type. We added as well an animated catering truck.
Unbelievable.
All of these services are now exposed in XML and are customizable using the SDK tools. Is it possible as well to create small scripted behaviors with your own objects and animations and to place them where you want? As you may have noticed, there are no parked planes all over the apron. These aircraft are actually part of the traffic. They can be called by the ATC, which means that they will perform some ground services on their own to get ready for a flight. They will then taxi to the hold short to queue before taking off. We hope you enjoyed this look into Microsoft Flight Simulator airport features and look forward to having you explore them in the future.
Okay, I don't know when Marianne is going to cut me off, but there's three more episodes, cockpits, and multiplayer and IFR instrument flying rules. It gets to be fairly technical, but I think you can see that the level of graphics and detail is just unbelievable, and you can go all over the world. I'm going to take a minute here and go to let's see here. I'm going to go to let's see the website. This is on the store, and it talks about, you can see what's required, system requirements, if you're interested. Actually, minimal, but the recommended is 16 megabytes, video memory, and all that kind of stuff. And as I mentioned earlier, and some of you may not have heard, to download the standard version takes 103 gigabytes. 103. It took me 3 hours on my connection, which is 100 megabits per second. I do have 8 gigabytes of memory and 16 gigabytes. Well, it requires at least minimum of 8, but I have 16, and sometimes it uses 12 gigabytes of that. So, and I said you can use, yeah, it's amazing. You can run it with a mouse and no keyboard, but that's cumbersome. You need a basic joystick, which is about $40. So why did I get it? You can fly all over the world, and the detail is fantastic, as you saw. So I am right now in a training mode in Sedona, Arizona. But I have taken off from the Oakland County Airport, and there's also, and I've flown over my house. I haven't flown over OPC yet, though. My son tells me there's a virtual reality version where you wear a mask and you can look out the window and see it in 360 degrees, which would just be fantastic. I may be able to demo in the future if we get together, give you my own experiences. But anyways, my final thought, Christmas is coming up. You may have a grandson or granddaughter who wants to be a future pilot. This would be a hell of a way to introduce them to that. They learn a lot of physics, a lot of stuff about the world. And by the way, I didn't mention, this is also available for Xbox. So any questions?
Have you looked at the NASA flight simulator?
No, I have not.
They got one for outer space.
Oh, wow. Okay. Okay. That's a good point.
Before we leave, if I may, going back to last week, if Ken is still here, can you tell us what was wrong with Dottie's wireless headphones? You're not unmuted. Ken, you're still muted.
Okay, let's see if that works. Can you hear me?
Yes.
Okay.
Yes.
There was multiple problems. The new box did not have an audio output on it. I don't know how the old one was configured. So the TV was actually connected to the headphones through a couple of RCA jacks that did not provide audio output. So basic troubleshooting, I brought over a pair of headphones that I knew worked, brought over a cable with a 3.5mm stereo and also an amplified speaker, which I also knew worked, that was mono, and some alligator clips. First thing we did was connect up to the TV's headphone jack output. We were able to actually hear the audio out of that. So then we removed some of the adapters and connected the wireless headphones through a 3.5mm to RCA to the wireless headphones. We had to turn up the volume a little bit on the actual TV set so that that output was sufficient. And then on the headphones themselves, we had powered that up and actually switched the channels so that it was in fact on the same channel as the sending unit that was charged, and she was operational. Do you need fills on that?
That's a lot of work.
It was really quite easy. I don't know what the original configuration was. I suspect the previous box in some way looped the audio back to the TV set so that the audio output from the TV on the back was able to work with the headphones, but I never saw the original configuration. So that's the solution that I left her with. I have not heard anything. If anybody else does, we're welcome to do additionals if there's a need for that. But we were able to get her operational, which is the important thing.
Right, right. Is she on the line today?
I don't see her.
I don't think so. I didn't see her either.
Yeah, okay, okay. All right. Well, I'm going to send in my list of videos if anybody wants to watch them again. But they're all on YouTube, and I hope you enjoyed this presentation because it really blew my mind when I looked at some of this stuff that they're doing. And again, I'm still impressed by what our computers can do and what these guys can do.
Hey, Len, what was the cost on that?
The cost on what?
The flight simulator, the software.
There's 3 versions of it. I don't know for Xbox, but the ones for the desktop, they're like the standard version is around $60. The premium version is $90, and the deluxe version is $119. I just started with the basic version. You can always upgrade.
Well, that's fantastic. I thought it'd be much more in the stratosphere.
Yeah, I know. Isn't that something? Now, you know, like I say, I had a joystick, and they were available at Micro Center for $40. But they got also all kinds of things like yokes, and you know, controls for the power, for the engine power, and all that. Lever stuff like that. That gets to be in the hundreds of dollars, and I guess you can go even more elaborate. You can go chairs and everything.
Yeah, you got to have a chair and foot pedals and all that.
Yeah, right. I'm way from that, but you know what? I'm looking forward to if they do the virtual reality one, because I do have VR available. I have the headset from Quest. So I because one of the things you know, you can sit in the cockpit and look out, and you push buttons to look left, right, and so on. and behind you, but there's also a mode where you basically look from, and you saw that where they show the complete airplane flying, and that's sort of what they call a drone mode. And so you can watch yourself fly from the outside of the plane, which is kind of neat. And then when you do in that mode, you can see more of the scenery. And I did fly from Oakland County Airport, which is about 5 or 6 miles due west of here, and flew over our house, although it's tricky. My son, who flies in Southern California with the mountains, he said he had a difficult time orienting himself in this flat Michigan country. But what really surprised me when you take off from the Oakland County Airport is the number of lakes that exist out there. Unbelievable. I couldn't believe it. And they show all the houses around all the lakes and everything. So you'll be able to see your own house. It may not look exactly like your house because, as he said, they use AI to kind of simulate houses. But anyways, it's pretty real.
Well, thank you, Len.
You're welcome.
What about Area 51? Can you fly over that?
Yeah, I mean, they say everywhere. Yeah, that's a good point. One of the things I've done is, because when I opened it up, it was nighttime, but as they explained, you can change the time of day and even the time of year. So, and by going on to clicking certain menus, I went all the way to Australia and flew around Ayers Rock, which was kind of neat. And so there's all these different places in the world. Maybe I'll try the pyramids, the Eiffel Tower, and various and that area you just mentioned. So yeah.
Well, I was specifically wondering if they restricted airspace, so you can't fly into the World Trade Center or Empire State Building, or military bases. I assume would be restricted airspace depending on what they did. So I wasn't sure how realistic it was for that.
You know, I don't know. You know what? I flew, I took the Highway 59 and I flew it out. I flew over the Selkirk, or what is it called? Selfridge Air Force Base. And I was surprised how it looked. I thought I was looking for more, I did see a long runway, but nothing stopped me from looking at it. So I don't know how they can prevent you from flying. You may not get the detail, or they may have, they may be camouflaged, the real important stuff, but I don't know. I'll find out. I'll ask my son if there's any areas that are restricted.
Well, all the restricted ones, they'll shoot you down. So for example,
I don't know. I haven't experienced that yet.
Try flying over the White House.
Yeah, I don't think they shoot you down in a Microsoft flight simulator.
Right. I haven't done that either.
Not a good simulation.
Right. Good point.
I'm using Google Earth. I've looked at fairly close to a lot of military bases, and it's pretty surprising what you can see. You can actually see what type of airplanes are parked at these various military air bases. And I don't know, there's a time lapse there because it's Google Earth isn't real time, but it's actually pretty close. I mean, it's fairly recent images that you get at these military bases, and you can see B-52s parked in some places. You can see where the jet fighters are parked, and of course, it's not current today necessarily, but you can get a feel for what's going on out there easily with Google Earth. So I assume the flight simulator should have access to all the same images and so forth that Google Earth would have.
Yeah. Well, the thing though, the real time is going to be that they're really talking about is the weather and traffic. I didn't mention that, but that in one of the flight sessions of the IFR, they talk about you can actually simulate the air traffic control in the area with similar planes that they get from these websites that show you the planes that are in the air. and they'll give you, like, what do they say, all the planes within 250-mile range. So yeah, you can fly. You know, and I'm not ready for that yet, by the way, a long time. I don't know, my son is. I'll have to ask him, but you know, and the other thing is you can fly multiplayer. That's something I look forward to, that my son and I will be able to fly together.
Oh, that'll be
the
great.
other thing they didn't mention is they have servers in the Eastern United States, I think in Europe and so on. And so typically when you log on, you go to the most closest server, but you can go to other servers. For example, if you're flying in Europe, you can go to the European server. The other thing is, the question is, how the heck does Microsoft support this? And if down the road in a year or 2 or 3, they're going to charge a monthly service. There's some speculation on that, but nobody's for sure. Well, Marianne hasn't cut us off yet, so I don't know.
I gave you right up to 1 o'clock today.
Okay.
We got the book club starting at 1, so I'm going to have to cut you off.
Okay, well, thanks for everybody listening.
Thank you.
All right. Everybody have a great night. And hey, we don't have somebody facilitating next week, so who's going to grab that? Donald?
Yeah, I don't think I'll be ready next week. They announced the census is going to be ending on the 5th, but that's back in the courts. So I don't know exactly when I'll come back and be available. I would think mid-month.
Okay. Yeah, this is Little Don. That was Big Don talking.
Oh, that Big Don. Little Don.
Little Don. I've got some stuff I could probably do next week, I guess.
All right. Thanks, Don.
Okay.
All right. Well, I will let you guys go. Have a really great week, and I'll see you next week, if not before.
Thank you. Okay. Thank you.
Bye.
Bye-bye.